The purpose of this video is to review over how to approach solving nuclear chemistry equations. Before we begin our nuclear equation, the first thing we need to do is look at the symbolic representation that will be used. Now, when we look at a nuclide symbol, for example, uranium-238, the 238 is written at top, the 92 is written below. The 238 is the atomic mass, the 92 is the atomic number. If we need to determine if this is naturally occurring uranium or is an isotope of uranium, we check the atomic mass. We compare this mass to the mass of uranium on the periodic table. If this mass is different from the mass on the periodic table, then we have an isotope. If this mass matches up to the element on the periodic table, then we have a naturally occurring element. So this right here does match up to uranium. This is naturally occurring uranium. Before we can begin solving a nuclear chemistry equation, we must first look at the type of radioactive decay that can be emitted during one of these reactions. We'll start with an alpha particle. Now, an alpha particle, when it's emitted, this is the symbol for alpha. However, it can be written as He42. Now, the 4 is the mass, where the 2 is the atomic number. A beta particle can be written with beta, or is more commonly written as the electron with 0 mass and a -1 charge. Gamma particles are pure energy, and so they are written with just a symbol. There will be no change in atomic mass or number. A positon is an electron that has a positive atomic number, 0 for the mass, and a neutron has 1 for the mass and 0 for the atomic number. So do keep each of these in mind, have these on your Fat Daddy chart, as we will be using these on our upcoming problems. Let's look at how to approach solving nuclear reactions. Remember that our mass number is on top, our atomic number is on bottom. Also, remember that when we balance equations, our components on the left of our yield symbol must equal our components on the right of our yield symbol. So as we look, we have a mass of 27 for aluminum, and we have a mass of 4 for our helium. Do remember that our helium is an alpha particle. So what we have is 27 plus 4, which gives us 31. Now when we look at the other side, we have the 30. We have 31 on this side, we have 30 on this side. Therefore, we need to include a 1, so that 30 plus 1 would equal our 31. Then if we look at our atomic numbers, we have 13 plus 2, that's 15. On the right of our equation, we have 15, so we need a 0 here. Now, what do we fill in as our symbol? If we review back over a slide or two back, we will see that a neutron has that very symbol. Let's look at example problem number 2. In this problem, we have 63 plus 2, that's going to give us 65. Notice that we have 2 times 1 or 2 for our neutrons, so we need to have 63 on top. We have 29 plus 1, which gives us 30. Now what we need to do is we need to look 30 up on the periodic table, and we will look up the atomic number for 30. When we do so, we see that we have zinc as our element. and therefore to balance this equation we would have 6330 zinc. Let's look at problem number 3. We have 44 plus 1, so we have 45 on this side. We have 44 plus 1. We have 20 plus 1 on the left, that's 21, and we have 21 on the other side. Therefore, we'll have another neutron. Continuing with our examples, you'll notice in problem number 4, we have uranium-234-92. We have our yield symbol. And on the right, we have an alpha particle. So we have 234 on the left. We have 4 on the right. Therefore, we need to add 230. Notice that we have 92 on the left and we have 2 on the right. So we'll add 90. We will look 90 up on the periodic table, and when we do so, we see that that is thorium. And so the answer for this equation is going to be 230-90 thorium. Now here we have 230-90 thorium on number 5, and that is going to yield a radon. And when we look at our Ra, it is 226, so we'll need to add a 4 here. So 226 plus 4 will equal the 230 we have on this side. We have 88, so we'll need a 2, so 88 plus 2 will give our 90. We look up 2 on the periodic table, that's helium, so we have released an alpha particle. Now let's take that Ra 22688, and that's going to give us Rn 222. We would need to add 4 to that. We look at the 88, and then we have 86 on the right side, so we would need 2. We look up the 2 on the periodic table. We have an alpha particle released.